Alright, so what we're going to do today is we're going to look at, if I'm not mistaken, and correct me if I'm wrong, we made it all the way through the delimited example, right? Including the definition or the translation? Did we look at that part?
I believe so.
Okay, alright. We're going to look at doing the first part of it two different ways then. The second part I didn't change. The second part I didn't change for XML or JSON simply because all it was doing was returning a single translated term. So there's no point in doing that in a more elaborate way. The reason that you use some of these methods is because you're returning multiple things back from your server-side script. And if you're only returning the one thing from the server-side script, then you don't gain anything by using XML or using JSON or anything. So we aren't going to change that part. So I'm going to actually do XML first, and then we're going to do JSON. We'll see how far we get today, Wednesday. If we have any left, we'll wrap it up. Otherwise, it will be a day for you to work on any assignments that you have outstanding still. So, Wednesday is our last day of class. You will have a final in here. The final will be online. It will be available from starting Friday. Actually, I'm going to go for this. I had the XML portion of it done two slightly different ways. Okay. But we're going to use the one way. Get the files moved into place, and then we'll go from there. First of all, as we start this discussion, what is XML? Very good. I like the way you put it, where you said it's like commentary on your code. With XML, what you do is you supply not just the data, but you supply tags, and those tags provide, you could call it a commentary or a description of what the code means. All right. Now, if you think about it, when we did delimited, all right, we had to know something about that data to process it. We had to know that it was delimited by colons and semicolons. We had to know that the first element was the term and the second element was the index. All right, if we just looked at that data, we wouldn't necessarily be able to figure that out. And if you can imagine a more extensive file that had a bunch of fields in it, it's not obvious what all the fields mean. The file just has the data in it with a few delimiters in it. XML has not just the data, but a description of the data. In other words, what it is and what it does. And it's accomplished using tags. Now, the difference is between XML and HTML is that with XML, you're free to define your own tags. In In other words, XML is not a specific language, but it's a format for you to define a method of data exchange using tags. So as long as the sender of it and the receiver of it are talking the same language, then you're in good shape. So let's look at an example of an XML file. All right. And actually, we're going to look at the specific example in this case. We're going to do the same thing that I always suggest doing when debugging Ajax, is we're going to look at the output of the server-side script, and that will be an example of a server-side of XML. So I'm going up in the address bar and I'm typing in dictionary1.php word equals A, just like I've done in the other example. And if you remember, we got back data separated by colons and semicolons in the other example. In this case, when we do it, we get something that looks very different. We get this. We get an error.
It does look pretty different.
Yeah, it looks a lot different.
I've seen that page before.
Yeah. Spelled dictionary wrong. There we go. All right. We get a series of tags, and it's tags that looks like, that act like HTML tags. XML, every XML file or data has a root node. In other words, it has one node that is the starting point for everything, ground zero. In HTML, that would be analogous to the HTML tag, right? Everything is contained within the HTML tag, the head, the body, etc. In this case, my root node is word list. And then I have an N word list at the bottom. So everything contained between here and here is my word list. Each word list each item within a word list is represented by an item tag. And that is represented by a word tag and an index tag. So there's no need for delimiters here. The delimiters, or what serves the role of delimiters, are the tags themselves. In other words, where is the start of the word? Here. Where is the end of the word? Here. What index goes with this word? Well, the index that's part of the item for that word goes with that word, and so on. So the nesting of the tags shows containment, and it shows a structure. Now, a couple things about this. First of all, this example is relatively straightforward, but XML is much better for representing a hierarchy. All right. For example, if we had multiple languages that we were able to translate to or from to Spanish, all right, we could have the item, we could have an English tag that would have the English word, all right, we could have a French tag that had the French word, we could have a German tag that had the German word, and so on down the line. So we could put all those tags inside the item, and we could show a hierarchy. All right, and then within the English tag, we could have the word and the index. Within the German tag, we could have the word and the index, and so on down the line. So we could really represent a hierarchy here. This particular case doesn't really take advantage of it. All right, you could argue that for this problem, XML is a little bit of an overkill because the data is simple. But if we had things like if you can imagine trying to represent a hierarchy with a flat file, with a delimited file, where you had personal information about a person, and you had the person's name, address, email address, and so on. Then you had emergency contact 1, emergency contact 2, and so on down the line. That would be very difficult to specify in a delimited file, especially if some of the fields were optional, right? Maybe a person only has 2 emergency contacts. What do you do with the third one? Leave them all blank? Or do you skip it? Or how do you arrange it? What if you had a list of medications a person was taking? How many spaces do you leave for that in a delimited file? Do you leave 10? Well, what if a person took more than 10 medications? So you could have a list of medications then. That gets very awkward to implement within a delimited file. It's very tricky. It's possible, right? It's possible to do that, but then your code has to become much smarter, and your code has to figure out how to associate things together. All right? With XML, the code doesn't really have to do that. All right? The code has a lot of help with that by virtue of those tags. And so XML is especially good when you're representing data where each piece of data is not necessarily the same. All right? It's not homogeneous data. All right? It's different data. All right? In other words, we could have people information, prescription information, contact information, doctor information, and so on, all in the same file. XML is very good at doing that. All right? Now, what file is likely to be bigger? What data, which way of passing the data is more bytes, do you think? Delimited or XML? XML easily, right? Because not only are you passing the data, you're passing a bunch of tags. And that is known as overhead, right? You need this stuff for it to work, but the actual data, if we look at just this item, the actual data is this and this. And we have how many characters of data overhead just to pass those 2 data items. All right? You can actually end up with more of these tags and overhead data than you actually have data. That's not unheard of. All right? If we were using delimited data, what were we passing? Well, we were passing the data and then a colon and a semicolon. For everything that we were passing, there was only 2 wasted bytes. Now, and I use the word wasted, I mean non-data bytes. They're not wasted because they serve a role. But there's only 2 bytes of overhead for each word. Here there is at least 5, 10, 18... Oh, there's 20-some pieces of there probably be, when I got done counting, 30 bytes of data in addition to the actual data itself that gets passed. So again, in this particular case, XML might be overkill. But I certainly didn't want to do an example using the most complicated thing I could think of. So bear with me and we'll see how this gets implemented within the Ajax application. Now, question. If we compare what we did last week with the delimited file and what we're doing now with the XML data, what component are we going to change? Are we going to change the client, the server, or both? We're going to change the client. How are we going to change the client?
We're probably going to tell it to look at those tags instead of having it like split based on the...
Exactly. So we're going to change the client. Specifically, we're going to change the section of code that parses the output from the server. All right? Do we have to change the portion of the code that makes the request to the server? And the answer is no. You're making the request the same way. You're calling the script, you're passing the string that's in the text box. There's really no difference in making the request in this case versus the delimited case. Now the data that we're going to get back is in a different format. So of course we're going to have to change the client to read that different format. All right? And of course we're going to have to change the server, because the server now has to make the data look like this instead of making it look like the way it did last week. So the correct answer is we're going to change both of them. We're going to change the server to output this instead of that. And we're going to change the client to parse the data differently. All right, so let's look. I'm just briefly going to mention the pieces that it has in common, but we're not going to spend time on those unless you have questions. All right, first of all, let's make sure that this works. I have the right code and I didn't make some kind of dumb mistake that way. Alright, sure enough it works. Oh, interesting.
Get a little extra there.
Get a little extra for your money's worth there, huh? We'll have to look to see why it is doing that. I am thinking I have debug code in there, but I could be wrong. Anyhow, we'll take a look at that. So it is working for the most part with a little bit of extra stuff in there. So, if we look at the operation of creating the request object and making the request, that's the same. We create our two request objects, one for the request to get the dropdown, one for the request to get the translation. We create our request object. Our get words looks the same. We look to make sure that there's something in the argument that we're passing. We clear out the dropdown if there's nothing in there. Otherwise, we make our request to call dictionary1.php, word equals arg entered. On ready state change, create dropdown, then we send the request. So, up through this part, it's the same as it was last week. Now, here's where we get into the change. And the change to the server isn't going to be drastic, right? Because the server was doing the work already. What was the main part of the work? The main part of the work was going through and looking through that array and looking to see if you had a match, and if you had a match, then outputting it. Well, that part of it is going to stay the same. It's going to do all that. It's going to look through the array. It's going to see if you have a match. If you have a match, it's going to output it. The only difference is the manner it's going to output it. It's not going to output it with colons and semicolons as delimiters. It's going to output it with tags as delimiters. And there is one other key difference. The output we're sending back to the client in the form of XML. All right? That's what the very top line of the code says. That what we're outputting to the client is XML. It's not plain text like we did before. All right? I'm going through and I'm going to accumulate in a variable, a results variable. I believe I did this. I'd have to spark my memory, but because I only want to send this once, because I'm sending a complete XML to it. And if I remember right, there were some issues if I tried to send more, if I tried to do a couple echoes. So I start with the starting word list tag. I loop through. Every time I get a match, I add to the results that I'm going to send the tag, starting tag for item, starting tag for word, the word, starting tag for word, or ending tag for word, starting tag for index, the index, ending tag for index, ending tag for item. You might wonder what the dot does. The dot's for concatenation. All right, it's a different way to concatenate.
Is that just for XML?
No, that's a PHP function.
Oh, really?
Yeah, we could have used it in other examples if we wanted to, but I think we used the magic quotes in PHP before. I'm not sure why I did it differently this time, maybe just to show you that there's another way to do it.
So the plus signs for when you use magic quotes and the dots when you don't, basically?
Well, when you use the magic quotes, you don't need anything really. You just include your variables inside the magic quotes. When you do a concatenation like this, where you're concatenating separate strings, you use a dot. If you use a plus, it will try to numerically add those. All right? And again, part of this is that PHP is a weakly typed language. So if you're adding two things, it's not obvious to PHP what those things are. You have to tell PHP, hey, I want to treat it like a number here, or I want to treat it like a string here. So that's why you have the dots and the plus. Okay, we set the be none to false because we do have some data. And we repeat this over and over till we're all done. Adding each time through the loop, if we have a match, we add that item tag. If we get to the end and there's none, we add an item tag saying no words match, just like we did before. We close our word list tag, and then we print the results. So, in essence, this is pretty much the same as what we did before. The only difference being is that we use tags to separate the pieces of the data as opposed to using the punctuation, the semicolons and colons. So really, yeah, this has changed, but it's not really changed all that much. All right? The real work, the real action goes on the server, on the client side, because the client now has to parse this totally differently. All right? It's not getting a string that's separated by colons and semicolons and delimiters, and it can't split the string into arrays and can't do any of that good stuff. It has to instead go in and parse it based on the XML tags. So, HTML or HTTP ready state equals 4. In other words, if it's finished. This was debugging code. I was demonstrating how to output a table as well. So I can comment that out. I'll leave it in, but you know, you wouldn't have to have this, anything related to the table you could get rid of and it would still work. All right. Now, right off the bat, other than that, we have something different. We are not grabbing response text. We are grabbing response XML. Why are we doing that? Well, because the results are coming back as XML. How does it get put in one versus the other? It gets put based on this up here. So by virtue of the fact that we said from the server that we're sending back XML, that's what this means, that answer gets put in a different place. Response XML. What we're going to do is we're going to do something similar with the arrays. We're going to construct those arrays in a very different way, though. All right? In the first example, we said, well, we split based on the colon and the semicolon and created arrays that way. Here we're going to use the get elements, notice an S, by tag name. And we're going to grab all of the elements that have this tag. So, if we look here, each item tag represents one word. So in this case, if I type in an A, I get 27 words. So there'll be 27 of these tags. So I'm grabbing an array of these tags. That is what this line does. And it stores it in a variable called items. Well, that's an array now, right? Because get elements by tag name is different than get element by ID, right? Get element by ID grabs the one thing that has a particular ID. Here, get elements by tag name grabs an array of all those elements that have that as a tag. So I get back an array, and I can loop through that array. Similar to what I did before, it's just I constructed the array differently. And the array contains different things. The array contains not just a string, but it contains this tag. An item tag that contains a word tag, contains an index tag. That's what is contained in each element of that array. Well, guess what I do again? I say, and this is a little hard to parse, if you will, word equals, what's the word part? The word part is going to be the thing in this that's part of the word tag. Well, I am looking in that array for whatever subscript I'm looking at. So the first time through it's subscript 0, subscript 1, 2, 3, and so on. I'm grabbing all the elements that have the tag of word in here. Well, I know in each one of these that there's only one word tag. That's the way I constructed the XML file. And therefore I can say, give me the first one of these. So, I grab then the first word tag that's part of the item. And then I look at each item going down the line. So, what do I have? I don't have the word. I have the word tag. That's what's contained in the variable word. Likewise, what is contained in the variable index? This index tag. Well, I don't want the tag. I want the stuff between the tag. All right? That's the value of my word. So what I do is I ask for the first child node value. All right? What does that mean? Well, if there were tags inside of this, it would give me the first tag inside of this. There are not tags inside of these tags. Therefore, first child gives me this. And the node value of that is that text right there.
So if there was a tag inside the word, let's say there's one of like English and French.
Right.
And you wanted the French word, would you ask for the third child? Or how
I don't know. I think you can loop through the children like you can loop through that. There is isn't a separate function for first child, second child, and so on. There's a first child function. But yeah, you would loop through it. Or, alternatively, you could look within this tag. You could get the tag name of, get elements by tag name of French. And you could grab that. And you could, essentially you could do this just like going one deeper. Alright? So here, I'm grabbing all the words. So that gives me a list of item tags. Whoops. Up here. I'm getting the tags by item. So I have a list of item tags. Here I'm getting the tags within each individual item tag that have a tag of word. I could go one deeper and loop through all of the tags, all of the word tags, and look for the tag of French or German or whatever. I do the exact same thing for the index. And then I create my drop-down option, same way as I did before. The only difference is the node value I use in creating the option. And then again, for good measure, I created a table. I don't know why. Someone in class must have asked a question, and I thought that was the best way to answer it. Questions about any of this? Thing to keep in mind is that in this particular example, XML is probably overkill. All right? XML works best when you have data where each piece of data is a little different. All right? In other words, here I'm simply always returning a list of words. Every item on the list of the words looks the same. If I was returning information about a patient in a hospital where I was returning patient information, address information, contact information, doctor information, prescription information, surgical procedure information, where each piece of information was a little bit different and had its own values, then XML would be the candidate for the job. All right?
So does that mean that Word and index are similar or dissimilar in terms of types here?
Word and index both relate to one word. One is the value of the word, and one is the index of that value in the... So yeah, I would say this data, if we look at the data, essentially we have a list of words. For each word, we have the word itself, and then we have its position in the array. So I would say in this case, yeah, it's similar. It's just two different things. It would be like if I had a word and the word's definition. It's all part of the information about a word. An example of where you would have more stuff would be if you had, let's say you were preparing a roster for nurses, all right, to look to see who's on the floor. You have a roster tag. Patient tag. Then you could have name, phone, and then you could have emergency contact. And for each emergency contact, you could have a name and a phone. And then maybe you'd have medications that the person was taking. With the drug and a dosage. And so on. Then, maybe you'd have stuff that was not even related to a patient. For example, who's the doctor on call? Who is, which nurses were staffed on the floor today? And so on down the line. You can have nurse or RN and a list of the RNs, and you could have the LPNs. In this case, the data is, different pieces of data are very different from each other. I mean, they're loosely associated with each other. Yeah, they're all in the same hospital, all right? But it's not like in this case where, yeah, this is a word, this is the index belongs to it. Here we have a list of the RNs that are on duty today, and here we have prescriptions and the dosages, and here we have the patient information. So that data is wildly different, all right? There's a structure to it. There's a hierarchy to it, all right? In other words, I can tell that this medication belongs to this person because it's nested in their patient data, all right? And the staff that's on duty is a part of this roster because it's in the roster tag, but the data itself is very different. That kind of thing is very difficult to represent in a flat file, all right? Very difficult. And it's possible. You end up typically doing something like this, where you have the first character of a row of data that describes the kind of data it is. So maybe a P would be the patient data. Maybe the first two characters, let's say. Maybe PA would be the patient. RX would be a prescription. NU would be, or RN would be a registered nurse. LP would be a practical nurse. DR would be the doctor that's on call and all that. And then you parse it and you look at those characters. But again, the knowledge, the understanding of that data format is baked into the program. Here the structure of the data is baked into the XML data itself. So I don't need to know anything about the details of this, and I can say this prescription belongs to this patient. How do I know that? Because it's nested within there. All right, it's the only logical way to do it. Other questions? So this could be powerful, but again, it's powerful. It's powerful because of the capabilities it has. Maybe that's just restating the obvious. Yeah, no, it isn't restating the obvious. By me saying it's powerful doesn't mean you use it in all cases, because some cases you're not going to really take advantage of the power. Then what? Then you're exchanging a lot more data because of all the extra overhead that goes across. And it's a little more complex to create and to parse and so on. All right? Questions about this? Next class, on Wednesday, we're going to look at JSON data. And JSON, J-S-O-N, JavaScript object notation, is another way of exchanging data between things. JSON is sort of between XML and flat files in terms of its complexity. You can do some more advanced things with JSON than you can with flat files, but it's not quite as fully featured as XML. So we'll see an example of that. And we'll notice that the pieces of our app that are different are going to be the same pieces that were different for XML. In other words, making the request is going to be identical. The server responding to the request, it's not going to be identical, but it's going to be really similar. The only difference is the extra stuff that we're putting in the data along with the data itself. Just like the extra stuff we put in when we use delimited data versus when we use XML data. And finally, the biggest difference is going to be the client parsing the data and outputting the results, because the data is coming back in a totally different format, so it's going to parse it differently. The last part, by the way, to kind of close the loop here, of actually displaying the answer, that part is identical. That part is not changed with XML, and it's not changed with JSON. This would truly be overkill to change this, because all we're getting back is one piece of data. There is no need to do any sort of delimiting or XML formatting or JSON formatting for that. It simply comes back as part of the HTTP response text, and we simply just display it on the page. All right, we'll see you over in lab. What kind of stuff will be on the final? Given that Ajax includes a server-side component and a client-side component, sort of by definition, the file is going to be comprehensive. It could include some PHP stuff, and it could include some JavaScript stuff. That being said, the focus is going to be on the Ajax stuff. The focus is going to be on this stuff. So if there is a JavaScript question, it's going to be about using JavaScript within the context of Ajax. So yeah, you kind of have to still know JavaScript, but it's going to be used in the context of creating something that you would use in an Ajax situation.